We were discussing electric field between two charged plates. This was our topic in our last class. We had started this topic. And I think we had discussed that these are the two parallel plates. These are the two parallel plates which are having this phenomena, electric field. The two versions of the field is there. One is called uniform field and second is called non-uniform field. The concept comes here that it's a signal strength. So normally signal strength varies. So signal strength varies. It is called, if signal strength varies, it is called non-uniform electric field. And if the signal strength is constant, it is called uniform electric field. Let's start this topic, shielding or screening. We are starting from here. This would be our first discussion concept. So give a heading, shielding or screening. First, copy down the definition. It is a technique used to protect sensitive components from the possible adverse effects of an electric field. Our syllabus got revised in 2023 last year. And for this paper, the paper in 23 was on the new syllabus. So in the new syllabus, this is not an important topic. This is something which I always do. I mention important topic, unimportant topic. So shielding or screening is not an important topic now. But anyways, we are discussing it. What is the concept here? That shielding means that you want to protect a sensitive component from electric field. Now, this is an electric field. This is an electric field. And if you put a metal sphere, if you put a metal sphere in between, the field lines converge. You can see the change in shape. Why this happens? The metal sphere acquire electrostatic induction. The metal sphere acquire electrostatic induction due to which the field lines converge through the metal sphere. This is called shielding. Now, if you put a hollow ring, the field lines converge through the ring and the central part is now empty. The field lines can not go through that. It is just like a roundabout. You can see here, this is a data cable, like HDMI cables, like USB cables, etc. So when you draw lines from here like this, and it goes like this, the field lines go across it. Like this. Now they do not enter, they do not enter the central region. This is called shielding. So we make a ring around the data cable so that electric field cannot enter the cable. And why we want that? Because it is like a protection. It stop interference. It stop interference, or you can say it's like a protection against external field. Now, after copying down the definition, this was the definition. Let me know, have you copied it? Okay, good. So you have to copy this screen. Let, let me know once you have copied it. Hazard of electrostatic. This topic is now coming. This is our next topic, hazard of electrostatic. The main hazard of electrostatic is a spark. Spark is a danger, as we had discussed in our previous class, I think so. Yes, in the previous class, we had discussed that a spark can produce a problem. Suppose you are refueling and lightning from the sky is a big size spark. The main hazard of electrostatic is electrostatic breakdown spark. A minor spark can also give a problem. Lightning from the sky is a mega size spark. This spark can produce a huge problem, and you know that lightning from the sky is very dangerous. Now, this is our next concept for today, that when something has a static charge, when something has a static charge, it can produce electrostatic breakdown. This is very dangerous. It can cause severe problem. So now we have this feature to come up. You have to copy this screen. This is lightning in example, lightning from the sky. This is an example. I want to show you this example to understand the potential voltage in this phenomena. This is a big scale example. This is a big scale example. There is some high sound. There is some high sound in this animation. Please careful. High sound. Applications of electrostatics. Applications of electrostatic. Now give this heading. Give this heading, application of electrostatics, photocopier, xerography, electrostatic precipitator, spray painting, gold leaf electroscope, Van de Graaff generator. Now, these applications are I can go through it quickly. Actually, none of them are in detail required. These are past paper examples. But first, you copy this screen, and then I can try to go through them quickly. This is they all work on the simple one concept that unlike charges attract each other and like charges repel each other. Now, these are the example. All the example work in a similar way, like one more example, inkjet printer. This topic was mentioned in 2023. Add this in the list also. Now, photocopier is a famous device. It is used to make copy of a document, and a photocopier actually produces a duplicate for a document. It works on the principle of electrostatics. Now, this is the case. It's a neutral paper, and you have a roller drum. We charge the paper. We charge the paper, and using a scanner, we produce an image on a photocopier page. I show you a quick animation on that. Now, look at this screen. This is called this is called the high voltage wire and drum. First, we charge the drum by rubbing, by friction. The drum is positively charged. If you have a laser printer at your home and you know how to take out the toner, you can see this drum, and this is where we refill the toner. Now, high voltage drum. Then after that, we reflect light. You must have seen, if you have, you obviously must have seen photocopier machine working. There is a scanner, light which passes through the document. This is a reflection of the letter P on the drum. After that, the toner sprays the ink. The toner sprays the ink on the drum. The toner sprays the ink on the drum. You can see the toner is spraying the ink droplets. The ink droplets are negatively charged and they produce an image fixed on the letter P. After that, a paper is brought and it is passed under the toner. The ink shifts to the paper. Now we use a pair of rollers which removes the extra ink. I repeat the slides. This is the drum. The drum is positively charged. Then, using the reflection, look at this reflection phenomena. Using the reflection, image is produced on the drum. Then we spray ink droplets. The ink droplets are negatively charged. They attract on the drum where the letter P was there and they stick on it. Then the paper goes through the roller. The paper goes through the roller. Ink transfers on the paper. There are two rollers, the pair of rollers, and ink passes in between. The paper passes in between. Extra ink has been removed. This is how photocopier works. Similarly, there is a concept of electrostatic precipitator, but I shift to a quick topic of spray painting. Spray painting is where you are using an atomizer, and this is a quick painting. Now it's common in our houses also, and we use commercial level painting by that, like with painting the cars. Now you have an atomizer and a nozzle, and the paint is inside the drum. When you run the apparatus, you positively charge the target surface. I repeat, the surface on which you want to put the paint, you charge it with positive. This is positively charged. Now the ink container, the atomizer, is charged by a negative terminal of a battery. This is the negative terminal of the battery nozzle. And atomizer is there. Then the nozzle, when you press the nozzle, the negative charges come out. These are repelling each other because they are same charges. Now the paint droplets travel towards the target surface, and as unlike charges attract each other, the paint droplets stick on the surface. That is why this paint is very shiny. I repeat from the start. Spray painting is a commercial level painting technique in which we have to paint a surface with a high quality response. Now, this is a nozzle, atomizer, and a surface which is target surface. Then the target surface is positively charged. Then nozzle is connected with a negative terminal of a battery. When you press the nozzle, negative charges come out and they spread out. They attract towards the positively charged surface and stick on it. This is how painting is done. This is called spray painting. We are starting our next chapter. You have to change the page. You have to change the page. This is our next chapter, and this chapter is very important, and it comes every year, and one unique property, it comes in all the papers. It comes in paper 1, it comes in paper 2, it comes in paper 4, a very, very important chapter. Current of electricity, and you have to see the one liner of this chapter. It is the study of moving charges. It is the study of moving charges. Introduction. Electric current deals with the moving charge carriers. This chapter deals with moving charge carriers. Electric current passes through conductors only, and conductors can be solid like copper wires, but in case of a battery solution, they can be liquid. Gases are generally poor conductors. Electrical conduction in metals in terms of movement of free electrons. Okay, you first give the first heading, introduction, and copy this screen. Now, give this heading, electrical conduction in metals in terms of movement of free electrons. You have to give this heading. Every solid, especially metal conductors, contain free electrons. Look at this diagram. Free electrons are moving like dodging cars. They are colliding with each other. They are moving randomly. In our previous chapter, the first chapter we did, in our previous chapter, we discussed this idea, free electrons, and we had observed this animation there. These are called free electrons. Now, physics says that these are the free electrons which are able to conduct electricity. Free electrons are responsible for electrical conduction. If free electrons are not there, if free electrons are not there, nothing can, no electricity can conduct. This is an example. Look at these electrons. These are called free electrons. Free electrons are moving randomly. These are the free electrons. So what we do, what we need actually, we need electrons to be moving in an order. When electrons are moving in an order, it is called electric current. So what is electric current? Free electrons are originally moving like this. Free electrons are moving like this. But when we generate electricity, the same free electrons move in order and they transfer electricity. Why they move in an order? Because we put a negative plate on one side and we put a positive plate on the other side. So after giving the heading, you have to copy this screen. After copying the statement, you have to copy this diagram. You have to copy this screen. Let me know once you have copied it. Now, what happens? What is the concept? These electrons are by nature moving randomly, but they can't do anything. Random motion, random motion cannot do anything. We always need an organized motion. So what we do, we force electrons to move in an order. We force electrons to move in an order. This is called electric current. So write under it that the free electrons are forced to move in a straight line. The free electrons are forced to move in an order, sorry. The free electrons are forced to move in an order. The free electrons are forced to move in an order. This is called electric current. This is called electric current. So we made this concept. Now we are moving towards the definition of electric current, and the symbol electric current is the rate of flow of charge carriers. Charge particles move in a particular speed. This is called the electric current. The symbol is I. Electric current is a scalar quantity. Now copy this screen. Electric current is the rate of flow of charge carriers. It depends how fast it moves, and it is the movement of electrons. So charge particles travel through a conductor. This is, you can see in the screen. They are initially moving randomly, but we actually guide them to move in an order when it becomes electric current. Now give a heading, formula for electric current. You have to copy the formula. Electric current. Now look at the unit. Remember, the unit of charge is coulomb and the unit of time is second. So when you make the unit here, the coulomb comes for charge and second comes for time. Coulomb per second is ampere. You have to now see this one, and the ampere has a translation with milliampere, and 1 ampere is microampere also. You have to copy now SI unit with conversion. The symbol, look at this symbol. This symbol we are using here, this symbol is used for micro, and this symbol is for SI, for System International. We have discussed it, but it's better if you copy it again. Definition of ampere. Now, this is something I want to discuss here, that in physics, just like the definition of quantities, we have definition of physical units also. In physics, just like when you say what is electric current, you can be also asked what is ampere. So just like the definition of physical quantities, we have definitions of units also. So when you want to define a unit, for example, I am writing a formula, F is equal to ma. The unit of force is Newton. The unit of mass is kg, and the unit of acceleration is ms minus 2. So when you define ampere, you actually have to put 1, 1, and 1. This is a technical and a very good method to understand. By this method, you can define any unit in physics. Write down the unit in breakup form and put 1, 1, 1, and then make a story. You can say that 1 Newton is the resultant force which produces an acceleration of 1 meter per second square in a mass of 1 kg. This is how in physics you can define a unit. For example, W is equal to FD, work is in joule, force is in Newton, and displacement is in meter. Now, how you can define it? It is 1, It is 1, it is 1. Okay, how you can make a story? 1 joule is the work done when 1 Newton force produces a displacement of 1 meter in its own direction. So similarly, what I'm doing here, I'm putting 1, 1, 1, and then I will make a story here to connect it. If 1 coulomb charge passes through a conductor in 1 second, the electric current is said to be 1 ampere. Now, you have to copy this screen, the whole screen. Now, I put my next concept. When you draw a graph of current against time, the area which is shaded here will show the quantity of charge transferred. This is the function of area. In our O-level physics, whenever sketches are there, two common parameters come in the paper. One is called the gradient and the other is called area. Area is the product of the two axes. So I repeat the concept. When you draw a graph of current against time, the area gives the quantity of charge. You have to copy this. Whenever we talk about an electric circuits are common in our houses. Electric circuit is a complete pathway for the flow of free electrons. Every electric circuit consists of two wires at least. Every electrical circuit consists of at least two wires. One is called the live wire and second is called the neutral wire. Now what happens that electrons go through the live wire. Electrons go through the live wire. Look, this is the live wire. Electrons go from this wire. When they reach the device, they give it energy and electrons then return home and then they reach the battery and come again. So there are always two wires. There are always two wires. One is called the live wire and second is called the neutral wire. This is why we always have a 2-pin plug in our circuits. When we connect it, we always get 2 circuit wires. Look at this animation. Water is flowing through a system and a turbine is moving. Similarly, when electrons are moving in a system, they transfer energy. Electrons are charge carriers and they transfer energy. I repeat the concept. Electrons are charge carriers and they are energy carriers. They transfer energy in electrical circuits. Some electrical circuit may contain the third wire also, which is called the earth wire. And this is visible when you have some circuits have 3-pin plug in your houses. So right under it, after giving the heading, give the heading electric circuit. Right under it that an electric circuit mainly consists of 2 wires. An electric circuit mainly consists of 2 wires. Number 1, live wire. Number 1, live wire. Number 2, neutral wire. So this is the concept of an electrical circuit. Then write under it that you have to copy this screen. So we keep it up to here. And if you copy it, we stop here and we will inshallah continue in our next class. So we keep it up to here and we will inshallah continue in the next class. Allah Hafiz.